Hey guys, today we're going to do 3-6 math of finance, and we will be able to use exponential functions and equations to solve business and finance applications related to compound interest and annuities. So, in business, as the saying goes, time is money, so we must pay interest for the use of property or money over time. When we borrow money, we pay interest, and when we loan money, we receive interest. When we invest in a savings account, we are actually lending money to the bank, and we receive interest. So, there's different types of interest. We first have interest compounded annually. If a principal P is invested at a fixed annual interest rate, R, calculated at the end of each year, then the value of the investment after n years is A is equal to P times 1 plus R to the n power, where R is expressed as a decimal. So, if we invest $500 at 7% interest compounded annually, find the value of her investment after 10 years. So, what do we have? P is equal to 500 because this is how much invested. R, we don't want percent, we want the decimal, so 7, we move it over twice, 0.07 as our rate, and N is 10 for the number of years later. We plug it into our formula. A is equal to 500 times 1 plus 0.07 to the 10th power. We plug this into our calculator. 1.07 to the 10th power times 500. A is equal to $983.58. Then we have interest compounded K times per year. So suppose a principal P is invested at an annual interest rate R compounded K times a year for T years. Then R over K is the interest rate per compounding period, and KT is the number of compounding periods. The A amount is the amount in the account after T years. So we're going to use this formula now. A is equal to P times 1 plus R over K to the KT power. Suppose Roberto invests $500 at 9% annual interest compounded monthly, that is compounded 12 times a year. Find the value of his investment 5 years later. So K is 12 because we are compounded 12 times a year. R is 0.09 because our interest rate is 9%. P is 500. Let's plug in. A is equal to 500 times 1 plus 0.09 over 12 to the 12 times 5 power. So I'm going to do 0.09 divided by 12 plus 1 raised to the 60th power times 500, and I get A is equal to $782.84. In the previous two examples, we have solved for A. What happens when we have to solve for the other variables in the equation? So if we need to find the time period of an investment, so Judy has $500 to invest at 9% annual interest compounded monthly. Compounded monthly means K equals 12. How long will it take for her investment to grow to $3,000? So now we know the A value, and we're looking for the T value. So we're going to plug in 3,000 is equal to 500 times 1 plus 0.09 over K, which is 12, to the k is 12 t power. Now that we have our variable and our exponent, this is like an exponential equation. So we're going to isolate what is being raised to our power. So I'm going to divide by 500. And 3,000 divided by 500 is 6. So 6 is equal to 1 plus 0.09 over 12 divided by 12 to the t power. I'm going to ln or log both sides. Which means I could bring my exponent to the front. So I have 12t log of 1 plus 0.09 over 12 is equal to the log of 6. And I'm going to divide by 12 log of 1 plus 0.09 over 12 on both sides. .09 over 12 is 0.0075 plus 1, which means we have the log of 6 over 12 log of 1.0075 is equal to t. So I'm going to put that into my calculator. Log of 6 divided by 12 log of 1.0075. And I get t is equal to 19.98 years. I'm going to take this and say this is about 20 years. And the reason I'm going to say this is 20 years is because I am not going to accept the 0.9 years. You have to take that 0.9 years, 0.98 years, and convert to months. So 0.98 is equal to how many over 12? X would be equal to 11.76 months. And that's why I'm going to say it would take 20 years. Oh, I'm sorry. We just did that. And then what happens when interest is continuously compounded? We are going to use A is equal to P times e to the RT power, where e is our base of our natural log. So, suppose Latasha invests $100 at 8% annual interest compounded continuously. As soon as you see the words compounded continuously, you know that we need to use A of t is equal to P times e to the RT power. Find the value of her investment at the end of each of the years, 1, 2, all the way to 7. So 100 is P, 8% means R is equal to 0.08. And then we plug in. A of 1 is equal to 100 e to the 0.08 times 1. 100 e to the 0.08 times 2 would be equal to A of 2. And so on, you should get these values. So at our first year, it would be $108.33, $117.35, and so on. That's all.